All right, greetings. It is Friday before the Labor Day weekend, so I'm kind of all in casual attire here. My UMKC Society of Physics students with the physics gang signs on the back, which is the good old right-hand rule of you got a positive charge going. This is the velocity of the positive charge. This is the direction of the magnetic field. Then this would be the direction of the force, your middle finger. So it's a three-pronged attack. They're all perpendicular, orthogonal, as we say to each other. But anyway, greetings. I didn't do a little video for the first exercise, number one. But exercise number two, I do this all the time, and I apologize. I kind of went off. Not going off on somebody, but just kind of got excited about the material, and so I kind of turned you all into dragster engineers. I'm not even a big racing fan, but I love the science behind things, and just to see if we can calculate what the horsepower of a dragster is. Okay, and just based on a video, if we can analyze it, and that's what I've done on the last 4 or 5 questions of the exam. So I thought I would at least help you get through it. Okay, so I'm gonna take my mug off the corner here because you don't need to see that anymore. There we go. All right, so let's go down here and let's just open up the exam. And I gotta open up my Ladybug too, make sure that works. You get 3 attempts. It's not an exam, it's an exercise. It's not an exam. It's just kind of a culminating exercise thing. Make sure this thing is up and working. All right, there we go. And hopefully we won't get turned off. Okay, so let's just kind of go through this. I'm gonna go through part of it really quickly because you already know a bunch of stuff. Okay, force is defined as, okay, what's the definition of force? Some of this you've already had from your previous, that was in your mini things. So here we go. How much power does a small, that's fine. Okay, that was that was in one of the slides. This is in one of the slides. So far so good. You're going, hey, this is great. I got this. It took you 3 minutes to get this done. Ha! Hang on. Here's an incredible video. Oh yeah, watch this video. Like, copy this to your browser and watch this kid. This Mondo Duplantis. I'd never heard of him before because I don't follow track and field that much anymore. And it is amazing. But anyway, he soared to a height of 19 feet 4 inches. That's like incredible. I mean, back when in the 70s, when I was a high school kid, and stupidly trying to play football and tennis instead of running cross country and doing distance. I mean, I needed to do a sport where all you have to do is put one foot in front of the other and go straight, or go run through the hills and things. So that's an easy one. Convert that 19.33 feet to meters. Okay, and let's assume Mondo has a mass. Now, this is what I do, and sometimes I get criticized for it, but I like building the previous question onto the next one, onto the next one, onto the next, so that you kind of go through a learning cycle like that, okay? Let's assume Mondo has a mass of 75 kilograms. It might even be less than that. How much work did the pole do to lift him to this height? The pole did the work, because it's what's bending and flipping him up in the air. All right, basically, and we'll learn later that during a pole vault, he's converting his kinetic energy, which is running, into elastic potential energy, which is the bending of the pole, and converting it to raising his gravitational potential energy. So how much work did the pole do? In other words, went to a certain height. He weighs, his mass is 75 kilograms. So you got to find out what his weight is, and then take times the height. So what are you talking about? Woo. All right. In case any of you have saw one of the greatest television shows of all time that was ever made, the HBO series Deadwood. That's what I'm talking about when I say that. Anyway, so let's magnify that a little bit. So remember, the work done is the force times the distance. Okay, and you got to do it in meters. So you got to find that force in newtons, which we know is mg. The force is equal to mg, and then you did that distance thing earlier. All right. So here you go. So he's up. The best I could calculate of his world record. Okay, so I watched a video of him and started and stopped it a bunch of times, and from when his feet, right when his feet left the ground to when he was at his maximum height, and that was and he let go of the pole. It was about 1.8 seconds. Based on your previous answer, in other words, based on the work done here, how much power? And so this is notes for exercise 2. Okay, so this is the notes for exercise 2. All right, so let's take a look. You calculated the work, so the power, remember, is equal to the work that you already calculated divided by the time. Okay, so that's not, so far so good. Now convert your previous answer to horsepower. We did that. There's a slide for that on what you multiply by to get that. Okay, so now here's where I go off, and I wanted to make sure that we, and like I said, I'm not even that big of a racing fan. I've got friends who are. Guess what those friends do for a living? They're engineers. They're mechanical engineers, and they just love this stuff. To me, I'm like, but I do like the science behind it. I don't like the noise. I don't like just standing around watching people turn wrenches. Other people like that stuff. That's never been my forte. But anyway, in the video, it showed the dragster went from a speed of 265 miles an hour, 4.3 inches. The first thing I want you to do is convert 265 miles per hour to meters per second. Let's do that. I think we've done that before, but let's do that right here. Again, this is problem 13. Okay, so we've got 265 miles in an hour, and we're going to do this a lot in this course, so let's just kind of get it out of the way. So we do 1600. Now I need meters per second, so I need meters up above and seconds down below. Okay, so I know that there's 1609 meters in 1 mile. All right, so that cancels my miles for me. Now I need to get per second. Well, in 1 hour there are 3,600 seconds, and basically 1609 divided by 3,600 comes out to be this cool little conversion thing that I tell my sportsters about. You just multiply that number by 0.447. Okay? Multiply 265 times 0.447 and you've got it. All right? So you can take that on to problem 14. Okay? Now, let's calculate the acceleration. Remember, acceleration is the change in speed, your previous answer, divided by the change in time. That's all it is. Okay? So far, so good. So on 14, piece of cake, the acceleration is equal to your change in speed divided by your change in time. And remember, this delta means change, okay, or difference. And their difference is usually the number minus 0, okay? Change or difference, okay? So far, so good. 15. How long is it? Oh, okay, so we're almost there. 15. A typical fuel dragster has a mass of 900 kilograms. What is the force? Okay. All right, so on 15, once again, on problem 15 here, once again, you're doing F is equal to ma. And we're telling you here that the mass is 900 kilograms. All right? And I thought my numbers when I got done would be so far off, but I want to tell you about what I found when we got done. I did a quick calculation to determine the distance and we'll do this calculation later. I just didn't think it was appropriate to bring it up right now because we'll look at what was the work done by the static frictional force to push the dragster that far. Hey, here's what I want to talk to you about. Okay, so I'm going to call up my except I'm afraid I'm going to lose it if I do that. So before we get to, I'm going to break this into two parts. I'm going to go ahead and stop here and with the thing, and then we will start here at what, problem 16. We'll do 16, 17, and 18 in the next video.